Hi, I'm Jake. I've been freelancing as a Flutter developer for a few years now. I've released a few apps into production, and over the last few years, I've realized that while Flutter is amazing at what it's intended to do, it's intended to help you make beautiful cross-platform UIs, it is difficult to make large, complex apps, especially if you're like me, where you want to roll out multiple apps quickly. And as a result, I've built Flood, which is a toolkit on top of Flutter to help you build apps much faster. In this video, we're going to take a look at the benefits that Flood brings, and we're going to build an entire production-ready to-do app in one video. First, to understand the benefit that Flood provides, let me go through some of the difficulties I've had with Flutter in the past. The first point is redundant code across projects. For example, if I want to add Firebase Crashlytics into all of my apps, I've got to go to the Firebase documentation, I've got to find the relevant code and copy paste it within all of my apps. The same thing goes for adding something like reading and writing to Firestore, handling authentication. What if I want to check whether this is the first time a user is running an app or not? What if I want to do a release automated deployments? This takes a long time, especially copy pasting and manually going through documentation and finding the relevant code. The second point is manual creation of form UI and handling validation in multiple places. In our to-do app, we're going to need to have both a create and an edit form for our to-dos so that you can create to-dos and you can edit them as well. Typically, you'd have to create both of these forms, define their UIs, handle validation, fallbacks, and initial values, and every time you update the to-do model, you have to go through and edit both of these forms. This is tedious and error-prone. The third point is tedious definition of data models, serialization, and security rules. In our app, we're going to have to create a to-do model, and then we're going to have to serialize it and deserialize it to and from Firestore. Typically, you're going to have to create a to.json and a from.json, and then every single time you update your data model, you're going to have to go through and handle both changing the data model and then also taking care of the serialization and deserialization. Also, if you create a new data model, you've always got to remember to update your Firebase security rules, which could also, once again, be a tedious and error-prone process. The fourth point is apps looking generic or requiring extensive styling changes. When I started working with Flutter, my apps looked like 90% of other material apps out there. They looked very basic. And then once I wanted to start designing and making my apps look unique but also good, it took a really long time to get this done right. I wish there was something that would have been able to make it so that I can easily implement a new style, just like HTML and CSS, where I can just implement a new style sheet into my HTML so my website looks good. I would wish that there was an equivalent in Flutter. The next point is time-consuming manual setup for testing, building, and deployment. At first, when I started using Flutter, I didn't know anything about automated deployments. I had to go through all of my apps, and I had to build and release everything manually to every single Play Store. Then I learned about Fastlane, which automated a lot of the process, but I still had to go and create the scripts myself, which took a tremendous amount of time. And then every single time I create a new app, I've got to set up all the API keys and secrets myself, and there was nothing really to guide me aside from the documentation, so it took a long time. Next point is limited access to device logs and file system for debugging. Whenever I send an app over to one of my freelance clients and they're working on it and they find some kind of a bug and it crashes, I wish there was some way that they could send me the logs of their specific session so I could find out what caused the crash in the first place. Also, if I'm serializing or deserializing data into the file system of the device, there's no real easy way for me to see what the device file system looks like so I can debug and troubleshoot any issues there. And the last difficulty is cumbersome serialization logic for testing repositories across environments. There are many times where when I'm developing, I wish that I could just use a locally emulated repository and authentication system, so I don't have to use Firestore or Firebase resources. I want everything to be local at first, but if I want to implement this logic, I've got to change my serialization from all of my data models so it can handle both local emulated repositories and Firebase. Same thing with authentication, and then I have to set up an entire process to figure out which kind of services should I be using. As a result of all the difficulties I've had with Flutter in the past, I built Flood, a toolkit that helps make your app development so much easier. It's composed of many different modules, each of which help you with a specific aspect of Flutter app development. Let's take a look at an overview of the different key modules and see how they can help you make apps much easier. The first module here is Pond. It provides streamlined app development using pre-built and custom pluggable components. There's no need to now scan the Firebase documentation to add Firestore or Firebase Authentication or Crashlytics. With just one line, you can easily add Firebase Integration into your project and everything works right off the bat. There's a huge array of pre-built components, and you can even define your own custom components that you can share across your projects. The next module is Port. It provides automatic generation of form UI with composable syntax for validation and decorations. What this means is you can simply define a port as a data model and then provide a list of fields for that form. For these fields, you can add decorations such as whether this field should be an email or a name or a password. You can add validation, fallbacks, and initial values to all of these fields. And then you can automatically render a port, and Flood will take care of finding all the correct input fields, checkboxes, dropdowns, everything that you need to make this port fully rendered and editable. The next module here is Drop, which provides simplified data modeling with auto-generated edit forms, serialization, and security rules. With Drop, you can simply define your data models and then have your edit and create forms automatically generated for you. It'll automatically handle serialization to and from Firebase and also locally emulated repositories. And with just one CLI command, you can automatically generate and deploy your Firebase security rules. The next module is Style, which provides customizable pre-built styles for consistent and visually appealing UI. You define your styles similarly to how HTML and CSS work. You provide an unstyled widget tree, and then you implement a style, which then renders everything and makes everything look nice. There's 2 pre-built styles, which you can completely customize, or you can create your own style completely from scratch. The next module is Automate, which provides automated testing, building, and deployment processes with a single command. With just one command, you can change the version number, set a changelog, and Automate will take care of testing your app, building it, signing everything, and then deploying to all the different deploy targets you define. The first time you run Automate, it's going to guide you through all of the API keys and secrets you need to input in order for it to be able to do its job successfully. Afterwards, you simply run the one CLI command, and it's going to take care of the entire process by itself. The next module is Debug, which provides integrated debugging tools for accessing logs and inspecting the device file system. It provides a special URL you can access, which can provide a bunch of troubleshooting information. You can view the logs of the current session and also all the previous sessions. You can easily share those logs, and you can even view the device file system for the app, both the storage directory and the temporary directory. You can edit files and you can delete them there as well. And the final module here is Environment, which provides seamless adaptation of repositories and services based on the current environment. So, while you're testing your app, you can use the testing environment to locally emulate all of your services and repositories. And once you're ready to test it on production, you simply switch the environment, and then Flood will take care of making sure all of your repositories are using Firebase or whatever cloud service you're using instead of your locally emulated repositories. To learn more about all of these modules and more, simply visit flooddev.com, which provides interactive videos showing you what everything does, and it provides a link to the documentation that you can use to learn more. In this video, we're going to build an entire production-ready to-do app. Here's what we're going to build. We're going to add authentication so you can log in, sign up, and log out. We're going to add some data models such as the to-do and the user data models, where the user data model has a reference to a list of to-dos. We're going to have cloud services. We're going to integrate this with Firebase Authentication and Firestore. But while we're testing and developing, we're going to use emulated auth services and repositories so that we don't use any Firebase resources. We're going to create a few pages. We're going to create the login and the sign up and the home page, where the home page is going to contain the list of to-dos for the current user. And then we're going to add the CRUD operations, where you can create, edit, and delete your to-dos. Lastly, we're going to show off how we can deploy Firestore security rules with just one CLI command, and how we're going to update the app icon. In order for you to get the most out of this video, here are some assumptions that we've got. First, that you have some basic Flutter experience. You should have been able to create an app by now, and as a result, you'll be able to understand the benefits that Flood provides. Second, you should have a basic knowledge of Firebase. Just a basic understanding of how authentication and Firestore works will be enough. Without further ado, let's go ahead and get started building this to-do app. In order to get started, we're going to take a look at docs.flooddev.com, and we're going to take a look at the Get Started page. Before I go here though, let me just briefly walk you through what the docs looks like. There's a lot of information here from the core concepts about using Flood, and then it provides documentation on every single module. It provides code examples and things to watch out for as you're integrating this into your app. But we're going to take a look first at the Get Started, and if you go down to the Use the Flood template section, we're going to see that this is the easiest way to get started with Flood. We're going to go ahead and clone the Flood template from GitHub. We're going to go here, copy the link, and then I'm using Android Studio as my IDE. Feel free to use any IDE of your choice, but I'm going to go ahead and get this project from version control, and I'm going to call this to-do app. Let's clone this project and get started. When you open up the project for the first time, you're going to notice that the project structure looks a little bit different than what you would expect with a Flutter project. Instead, we're using Melos to link two projects together for our app. We've got a core project over here, which is a typical Dart project, and in here, we'll notice that there is no dependency on Flutter. The purpose of the core project is to store your business logic that should be shared across all your apps, and it provides the test directory and a tool folder which hosts all of your CLI automations. Your CLI automations cannot depend on any Flutter dependencies. So, as a result of this being a pure Dart project, your automations can read your data models and then do automations based on that. And then we've got an app project over here, which has your typical Flutter project structure. We've got the Android folder, the iOS folder, and so on. If we take a look at the pubspec.yaml here, we see that this does have a dependency on Flutter, and it also has a dependency on the core project. This is going to store all of your Flutter-specific code for your app. The README will provide a list of instructions on how to get started setting this up to make this app your own. Let's follow along with this README here. In order to initialize this app, we're going to need to come up with a name for the project. It's going to be represented as this variable in the file examples below. Let's call our project Todo. Now let's rename the template directory to Todo and the template core directory to Todo core. Let's go ahead and do this. I can do it like so. Next, in step 3, we need to replace the template with Todo in the root pubspec.yaml. Let's go over here and replace this with Todo, and let's also replace this with Todo. Step number 4 is to go to the Todo pubspec.yaml and replace all instances of template with Todo. Let's go ahead and do that. And I'm just going to use Command R to find and replace all instances of template with Todo. Step 5 is to do the same thing with the core project. Step 6 is to look at the melos.yaml file at the root, and we're going to replace all template with Todo and set the repository to the URL of your GitHub repository. So I'm going to go to melos.yaml, replace template with Todo, and we're going to replace this with our GitHub repository. Because I'm not actually going to push this to a GitHub repository, I'm not going to change this field, but if you are pushing to a GitHub repository, you should set this field to your GitHub repository. You can check out the Flood example project on my GitHub to see a very similar app to this so you can follow along. Let me go ahead and also replace this with Todo and this with Todo. Next, step 7 is to replace every instance of this with Todo and every instance of this also with Todo. So let me go ahead and copy this, Command-Shift-R to do a global search and replace, and let me replace this with Todo. And then let me do the same thing with, instead of template core, let's just do regular template and replace this with Todo. The next step is to go to the automate.dart folder, and we're going to replace every instance of template with Todo there as well. So go to the core project, tool, automate. I'm going to once again replace template with Todo, and we've got that all set up. Next, we're going to replace every instance of this with our app identifier. For this app, I'm going to use com.example.todo as my app identifier. Let me once again do a global search and replace and do com.example.todo. Replace all, done. The next step is to do a project-wide search for any instances of template and replace them with what you need for your app. So if we do Command-Shift-F and we search template, we can see every instance of the word template and see what we need to replace. The first thing I see is info.plist has the word template for its bundle display name. So let me replace this with Todo example. Let me copy this. And then we also see the same thing for CF bundle name. So let me replace that here as well. I see the word template used in the README. I'm not going to modify the README here. I see some pubspec.lock files. We don't need to edit those. And then I see an index.html that is used as a title. Let me go ahead and replace that with Todo example. And then a manifest.json. Let me replace all templates here with Todo example. And those are all the templates that we need to replace. The next step, 11 here, is to search for Todo across the project to find what steps you should take to customize the project. I'm not going to do that right now because I will actually be walking through every single one of these in my walkthrough of this video. But when you're starting your own project, you should be doing a global search for the word Todo and find what you need to do to customize the app. Let's take a look at the workflow of how we get these two projects working together using Melos. In the README, you're going to see a workflow section that you can follow along with. The first thing you're going to need to do is install Melos. And then once you do that, you're going to want to bootstrap your two projects together. You can do this by going to the terminal, typing in Melos BS or Melos bootstrap. And once you do that, it's going to go and run Dart pub get on a Dart project and Flutter pub get on a Flutter project. And it's also going to link the two projects up together. Before we run the app, let's go ahead and update the app icon so that when we launch the app, it's going to use our correct app icon. We're going to show off the automate module here, where with some CLI tools, we can automate a lot of the processes that we use to make apps all the time. The first thing we're going to need to do is if you go to the app project and under assets, you're going to see the currently existing app icon right here. This is the Flood logo, and we see there's a logo foreground and a logo foreground transparent file. We can go ahead and delete these because we're not going to use the Flood logo as our logo. We're instead going to I'm going to drop this file in here, and I'm going to rename it to logo foreground, and I'll copy paste it and create another one called logo foreground transparent. And this is going to be the logo that we're going to use for our app. This is an AI generated image here. Now what we need to do is we need to go down to our terminal and we need to cd into our core project, and then we need to run dart tool automate.dart native setup. Native setup is going to go ahead and set up our app icon and our splash screen. You're going to see that it failed right away, and that's because Dart has recently been changing how you run Dart commands. We need to pass in this flag here in order for it to work correctly. So let's go ahead and run the command again, except let's pass in this flag. There we go, it's completed. Behind the scenes, it uses some Flutter packages that you may be familiar with, but instead of you needing to go find the documentation and create the YAML files yourself, this automation sets that all up for you and runs the command in the background. Now, if we go ahead and double check, if we go to the Android app, source, main, res, and then just one of these drawable folders over here, we're going to see our logo here instead of the Flood logo. Let's go ahead and run the app now. If you go down back to the app project and then you go to lib main.dart, you can go ahead and debug the Flutter app like so. The app has been built, and as you see, we're using the logo here, and when we click into it, we've got our template up and running. Before we get started working on our app, let's go and see everything that the Flood template provides us right off the bat. The first thing we're going to notice is a banner up here that says production. This is the environment banner. This shows us the environment that our device is currently running in. If we want to change the environment, we can go into our app project, and under assets, let's create a new file called config.overrides.yaml. We can set the environment here. I'll set it to testing for now. This locally emulates all auth and services such as your repositories. You can find more about what each environment does in the docs. If we restart the app now, we're going to see that we are in the testing environment. The purpose of the config overrides file is to store any configuration that should be only for your device. Don't store anything here that should be shared with other devs on your team. The Flood template also provides a debug page that you can use to troubleshoot your app development. Let's take a look at it now. If you go to the bottom left of a screen and you long press, a URL bar is going to show up here. This allows you to navigate to any page, even when you're on a mobile device. Let's go ahead and type in _debug here and click go. This is going to take us to the debug page. We can go to the logs page here to see the logs from a current session, and it's even going to show us logs from previous sessions if we're in an online environment such as production. You can also share your logs by clicking this. The device files page shows us all the files that are on the device for this specific app. We can see that Google Fonts automatically added some font files here. We've got an app usage folder that we can take a look at, and we can even edit files, and we can even delete files if we want. This also gives us a temporary directory that we can look through as well. We can take a look at the drop page, but I'm going to save that for a bit later because that requires some more knowledge about what drop is. And then we've also got a reset page. If we click here and we click the reset button, it's going to emulate us installing the app for the first time. It'll delete all Flood related files and essentially allow you to see what it would look like to install the app fresh. One of the first things we're going to want to do is we're going to set our style and then verify that our style looks good. If you go into the app page under lib, presentation, and style.dart, you're going to see a code section here where you can customize your style. We're currently using the flat style, and we've got a primary color and a background color. Let's change this to match the app theme. Let me grab that from the foreground logo image here, and I can use the color picker and just grab this light blue as our primary color. And I'm going to go ahead and paste that here. And then for the background color, let me go and use this as the base for that. But then let me go ahead and make this a much darker color. I'm going to copy this and try that. Now, if we restart the app, we're going to see the new style in action. And this doesn't really help us though. It's just white on a dark background. But if you go down to the URL bar and you type in _style guide and click go, you're going to see a fully built style guide that's going to showcase what your app's going to look like with this style. We can go and see what different cards look like. We can see what a bunch of different inputs are going to look like. You can even click on these and see what they're going to look like. For example, this date picker, or there's this color picker. We can see what kind of loading spinners are going to show when we click buttons, and so on. You can see what images are going to look like, other miscellaneous things, and then you can get a whole bunch of text here as well. So we're going to stick with this as the baseline for our app. Let's go ahead and start creating our login page. To do that, we're going to go into the app project here under lib, presentation, and pages. We're going to create a new page here. We're going to call this loginpage.dart. I've got a snippet here that's going to help me fill in the right code to create a page, but essentially a page requires two things. It requires a route and it requires a page. The route tells Flood where the page is located, and the page defines how it should be rendered. So here in this login route, we need to define that it is going to be underneath the login path, and we need to define an on build for this page. For now, I'm just going to return a styled page, and I'm just going to return a body that has a styled text.body of login, just for testing. Now that we've got this set up here, we do need to configure this so that Flood recognizes this route and page. We need to go to the pages pond component, and then we need to add a new entry into this pages map. We need to add login route is mapped to login page. Now, if we restart the app and we go down to the URL bar over here and we go to the login path, we're going to see the login page. You can see a little glimpse of the word login here. Let me go ahead and wrap this around a center to show it a bit more easily. Boom, we've got login over here. The reason that this page shows up whenever we type in /login is because the route is defined to work in the login path. Because we want to start working with our login page first, it will be annoying that every single time we restart the app, we're going to need to go down, access the URL bar, and type in login and then click go just to see the new changes. We can fix this by adding a redirect to the home page so that it will automatically redirect users to the login page when they first open the app. What we can do is we can go to the home page here, and then currently the home page is set to be just an app page, but let's go ahead and set it to be an app page wrapper. We can then define the app page that it wraps. We're going to return just a regular app page here of type home route. And then we're going to add with redirect. In this redirect, we're simply going to return login route.route data. What this does is an app page itself defines functionality such as what happens when you build it and then the redirect. An app page wrapper allows you to compose functionality on top of the current page. So in this case, we're saying that the home page is defined by the home page plus a redirect here. And the cool thing is that we can then chain other things, such as setting the parent of this page or setting another redirect if we want another conditional redirect. So let's go and see this in action. If we restart the app, before it showed us the home page right away, but here we're seeing that we're getting redirected straight to the login page. This is exactly what we want. With that, let's go ahead and start working on our login page. Let's open it up, and then inside of the on build here, instead of having a center as a body, let's go ahead and use styledList.column, and then we're going to add a scroll bar to this, and we're also going to center everything horizontally. With this, we're going to pass in some children, and we're going to add a styled image.asset, and the asset path is under assets logo foreground.png. And let's see what happens now. We're going to see a page here with a humongous image. Let's go ahead and make this image a little bit more manageable. Let's set the width to 200. There we go. And then we're going to wrap the entire list within a safe area so that this image doesn't bleed over to the notch. And then we're going to go ahead and we're going to add a styled text.xl and we're going to add welcome to example to do. We've got a extra large text over here, but let's make it look a bit better. We're gonna make it bold, and we're also gonna make it use the display font. This looks a lot better. Now we're gonna add a styled divider, and we've got that here. And the next thing we need to do is we need to now add the login UI. We're gonna ask the users for their email and password, and then we're gonna provide a login button or a sign up button if they haven't created an account yet. You've seen a lot of usage of styled widgets. While I don't have the time to go into the details of every single one of these, you can learn more about them by going into the docs. Let's go ahead and build the UI that's gonna accept the email and password from the user. Typically, you would hard code the UI and create an email and password field, but we're gonna use Port to automatically generate the UI for us. If you wanna learn more about Port, you can check it out in the docs as well. To use Port, we're gonna need to create a port in the build method here. We're gonna create final login port is equal to port.of, and then we're gonna pass in a map that maps a field name to its field type. So we're gonna want an email here to be represented by a portfield.string, and then a password here represented by portfield.string as well. This says that there's going to be an email field that is a string and a password that's a string. Now we're going to use this login port down here underneath the style divider. We're going to use a styled object port builder where you pass in a port, and then it's going to automatically generate the UI for the port. Before we do this though, there's a few things we need to take care of. This port is going to be rebuilt every single time the page reloads. We want to make sure that this is only built the very first time the page loads. Flood uses Flutter hooks a lot behind the scenes, and this app page wrapper here actually provides us a hook widget that we can use to tap into the Flutter hooks. Let's go ahead and use a use memoized hook so that we only build the port the very first time this page loads. Now we can go ahead and run and see what happens. Great, we see two fields here. There's obviously no helpful information as to what these fields do, and there's no validation. Let's go and change that. We can add more functionality on top of these port fields by just simply adding .with and then the extra information. We're gonna add a display name to both of these, where the email field is gonna have the email display name and the password field is gonna have password. Now we can also add .isNotBlank to both of these because they are required. And then for the email field, we can add .isEmail. And then for the password, we can add .isPassword. Let's go ahead and see what happens now. We need to restart the app in order to see our changes because we are using useMemoized. Sweet. We see an email field here and a password field here. They're labeled correctly. And if we go and we turn on the soft keyboard on the device itself, we can see that it provides us the @ symbol because this is an email. And then the password, it's going to provide us a suggestion to use our saved passwords. And then as you type, it's going to obscure the text. This is all handled automatically for us because of these decorators here. Now let's go and add a login button to see how we can submit our ports and get the data from them. So if we go underneath the styled object port builder and we add a styled button, we can add a label text to it of login, and then we can add an onPressed. And we're gonna go ahead and first, we're gonna need to submit the port. So we're gonna await login port.submit, and this is going to validate the port and then return the values of the fields. And we're gonna wanna save that. So we're gonna do final result is equal to that. And then if the result is not valid, we are just gonna return. We don't want to do anything if the result is invalid. For example, if users have left the fields blank. But if it is valid, then we're gonna go ahead and just print the result and see what happens. Let's rerun this, and then let's see what happens when we run login when these fields are blank. We'll see that they provide us validation errors. What happens if I type in some random thing into an email? It's gonna say that this must be an email. But then if I go ahead and I type in a valid email and a valid password, and I click login, it's going to give me an instance of port submit result. Let me go and find some more helpful information here by printing results.data instead. If I run this and click login, we're gonna see a map of our data. Here it's a map that maps email to what I've typed in here and password to my super secret secure password. In order to help with testing, let's go ahead and make it so that every single time we start our app in a testing environment, it's going to automatically log us into an account. And then let's provide a logout button over here that's gonna allow us to test logging in and logging out. Let's start by making it so that every time we start the app in the testing environment, it's going to automatically create an account for us. So if we go down to the app project, lib, and then main.dart, and you scroll down to the bottom, you're going to see a function here called setup testing. Here is going to be code that runs every single time the app starts in the testing environment. What we're going to want to do is await corepond context.auth core component.signup. You can learn more about auth and all of its functionalities in the docs. But here, we're going to go ahead and sign up and create a new account. We're going to use authcredentials.email, and we're going to pass in an email of asdf@asdf.com with the password of this. We're going to go ahead and start the application here. And we'll see in the logs here that we have signed up for a new account. You can see that we have called sign up and we have an account that was created for us. Now, let's go ahead and show the currently logged in user in the login page here just for testing. If we go to the login page and we go up to the top of the build function here, we can go ahead and use final logged in account is equal to use logged in account or null. Because we're going to be able to log out, we do need to handle the null exception of when there is no logged in account. So this hook here is going to update every single time the user that is currently logged in changes, and we have access to their account here. Let's go ahead and underneath the login button, just simply print a styled text.body, and we're going to pass in the logged in account ID. Because this is a nullable account, we're going to go ahead and add the question mark here, and if there is no logged in account, we're just going to print NA. So if we restart the app, we're going to see the account ID of the currently logged in user. Let's now also go and create a new button called styled button dot, and we're going to make it a subtle button so that it's not as emphasized as the login button. And we're going to make it say log out. And then whenever you press this, it's going to await context.auth core component.logout. Let's see what happens. We have a logout button here, and when we click it, we see that we're not logged in anymore. Notice I didn't need to do any state management on my own. Flood was able to take care of listening to the logged in user and handled updating this for me automatically. Let's now make it so that the login button, instead of just printing the results, it actually attempts to log the user in. So here, we're not going to need to print anymore. We're going to instead await context.auth core component.login, and we're going to pass in email auth credentials. And for the email, we're going to use the results.data of email. And then for the password, we're going to use results.data of password. Let's format this and see what happens. Now, once again, if you press login but you don't have correct validation, it's not going to do anything. But if we pass in asdf@asdf.com and we use our password and we click login, we're going to notice that the validation errors are gone and we're now logged in. We can log in and log out with ease. Let's go ahead and see what happens whenever we try to log in with an account that does not exist. If we simply add a to the end of this, this is not an account that exists. If we click login, this is going to have a loading indicator over here, and then we're going to have some errors in the logs. That's helpful for us, but the user doesn't know what happened wrong. They may have mistyped their password. So what we want to do is show the error to the user, and the way we can do that is by wrapping this call to login around a try catch. And we want to grab both the error and the stack trace. And then instead of just printing, we're going to want to run context.logError, where we pass in the error and the stack trace. This uses the logging module to store the logs and track them. You can learn more about the logging module in the docs. But not only that, if E is a login failure, we can actually grab some specific text from it to help the user. This login failure is a special class that Flood provides for whenever something wrong happens whenever you're logging in. What we can do here is we can do login port.set error, and we're going to set the email fields to have the error of e.display text. Now, if E is not a login failure, what we can do is set login port error of email to e.toString. This code here is a bit verbose. What we can do instead is we can do login port.set error of email to e as login failure, which is going to attempt to cast E to a login failure. And if it was successful, it's going to return the login failure. Otherwise, it's going to return null. And we're going to use the display text if it is a login failure. Otherwise, we're just going to use e.toString. This simplifies the code here and makes it a little bit less verbose to work with. Essentially, if E is a login failure, we're going to grab its display text. Otherwise, just print the error message itself. If we're going to do a hot restart over here, and we attempt to do the same thing. And this time I'll type a password incorrectly, and we click login, we'll see that you cannot log in when already logged in. This helps the user so much more to understand what's going on. Currently, we're able to only log in to the account that was created whenever we started the app. Let's go ahead and add a sign up page so that we can create new accounts. The first thing we can do is we can add a sign up button next to the login button here. If we go up to the button here, we can go ahead and wrap this in a column, but then we're going to change it from a column to a styled list.row. And we're also going to center the row so that it's centered horizontally. Next to the styled login button, we're going to add another button here, styled button, and we're going to make it a strong button to make it very visible. The label text here is going to be sign up, and whenever you press it, we're just going to print hi for now. Let's see what happens. We see that we have a sign up button here. Awesome. Let's go ahead and add another page in addition to the login page. We're going to go here, type in sign up page.dart. I'm going to use my snippet. If you'd like access to these snippets, let me know down in the comments and I can create an IntelliJ plugin for you. With the signup route, let's go ahead and add it so that it works with the signup path. And then let's go ahead and just for now add a scaffold page here, styled page with a body of a center whose child is a styled text.body that says sign up, just to see that it's working. Don't forget to input the signup page to this page component here. We need to add signup route is mapped to signup page. Let's rerun this. Let's go ahead and make it so that the signup button here navigates the user to the signup page. If we do context.push, we can use the signup route, and it's going to navigate us to the signup route automatically. If we go ahead and save this and see what happens, we'll see that we're taken to the signup page. Let's go ahead and add some content in the signup page so that it actually allows the users to sign up. The first thing we're going to want to do is we're going to want to create a port called a signup port. And it's equal to use memoized with port.of, just like the login page. In fact, let me go ahead and copy the port from the login page because the functionality is going to be really similar here. In addition to just the email and password, let's also add a name field so that the user can type in their name. And then let's also add a confirm password where the users can confirm their password before they create an account. In the confirm password, you need to pass in the name of the password field so that the validation is going to automatically check to make sure that the confirm password field matches the password field. Also note that the .isName, the only purpose it provides here is to allow the autocomplete to suggest names that were passed into text fields in the past. With that, let's go ahead and replace the center with a styled list.column.width_scrollbar.centered, just like the login page. And let's add some children here, which in this case is just going to be a styled object port builder of the signup port. And let's see what it looks like right now. It looks great. We see our fields, but it's cropping into the notch. So let's wrap this styled list within a safe area. And let's try again. And we see that it works fine here. Let's go ahead and also add a styled button .strong, and it's going to have a label of sign up and an on pressed. That's going to function very similarly to the login page. Let's go ahead and actually copy the functionality of the login button from here, and we're just going to make a slight little tweak. We're going to first change this so that instead of the login port, it's going to use the sign up port. And then instead of logging in, it's going to sign up using the auth module. And then instead of setting the login port exception here again, we're going to set the sign up port. And also, instead of login failures getting passed whenever you try to sign up and something incorrect happens, we're going to have sign up failures. So let's use this instead. This should be all we need to do to add signing up. Let's go ahead and restart the app. Let's log out so that we have no account right now. And then if we go here and we type in a name, asdf@asdf2.com, we pass in a password and a confirm password, and we click sign up, and we go back, we're going to see that we've got an account ID here. This is the account that we just created. Let's go ahead and try to create an account with the same email that we just used to see what happens when there's an exception that occurs. we're going to see that an account with that email already exists. Our current implementation allows us to both log in, sign up, and log out. Let's go ahead and clean up our login and sign up pages just a little bit. Currently in the login page, we're showing an account ID and a logout button. Let's go ahead and hide these for now because they're not going to be there whenever we're done with the actual app. So in the login page, we can go up here and remove this code. Next, what we want to do is that if the user starts typing an email here and they press sign up, we want to pass in the email and password that they were typing in earlier into the sign up page so that they don't have to retype everything again. So let's go to the sign up page and go up to the sign up route. We're going to add some fields here that can be passed in whenever we create a sign up route. I've got a snippet here that allows me to easily type in fields. We're going to create an email field, which is going to be of type string. And then we also can do a password field, which is also going to be of type string. If we wanted these to be required, we could add a .required at the end here, but we don't need to do that here. The user doesn't need to type in an email or a password to get to the sign up page. Before we're done here, let's go ahead and add this to the query properties of the route. And then whenever we are in the login page, whenever we are going to click the sign up button, whenever we push the sign up route, we're going to set the email property to the login port the login port of email. And then we're also going to set the password field to login port of password. You may be wondering why we're not submitting the port in order to get the email and the password. And the reason for that is because if we try to submit the port, but there are no values there, it's going to throw an exception. This here allows us to grab the raw values from the port without first submitting it. So let's go ahead and see what this looks like. If we restart the app and we just type in some random email and password and we press sign up, we're going to notice when we take a look at the sign up route here that it was passed in an email and a password query parameter as well. Typically, you can pass in parameters using the query parameter section here, but this can expose some dangerous information that we don't want other users to be able to see. So let's actually, instead of passing the email and password as query parameters, let's add them as hidden parameters. If you go to the sign up page and instead of query properties, we do hidden properties and we restart the app, we'll see that whenever we click the sign up page here that the email and password have not been passed in here, but we still don't see the default values showing up here. Let's go ahead and set the port initial values to those values that were passed in from the login page. If we go down to the port that we're creating in the sign up page and we go to the email port field here, we can pass in an initial value of route.emailProperty.value, and we can do the same thing in the password field like so. As you can see here, whenever we build the sign up page, we're given the sign up route, and we can use any of the properties in this route whenever we build the page. So let's restart and try again and see if this works. We'll see if we type in email for the email and password for the password, and we press sign up. We're going to see that the email and the password were passed in through a hidden route information, and then it was extracted and pulled into the port as initial values. The only other thing I want to clean up here is to add an app bar here that says sign up. Inside of the sign up page, if we go down to the styled page and we add some title text here that says sign up, we'll see we've got a sign up app bar here with also a back button that we can then go back to the login page easily if we wanted to. Let me also remove the safe area from the styled list because it's not necessary anymore because the app bar takes care of it. Currently, whenever you start up the app in the testing environment, it creates an account for you automatically, but the homepage will still automatically redirect you to the login route no matter what. Let's go ahead and change this so that the homepage is going to check whether you're logged in or not. And if you're not logged in, it's going to redirect you to the login route. Otherwise, it'll keep you on the homepage. Let's go ahead and expand this redirect over here, and we can check whether the user is logged in or not by doing context.authCoreComponent.loggedInAccount. And if the logged in account is equal to null, we're going to return the login route. Otherwise, we're going to return null, which means we're not going to redirect the user. If we restart the app, we're going to see that we are kept on the home page here. And if we go to main.dart and we comment out this code that is going to automatically sign us up with a random account, and we restart the app, we're going to see that it takes us to the login page over here because we don't have an account. Let's make it so that whenever we log in or sign up, it takes us to the home page. And let's also make it so that there's a logout button in the home page that'll take us to the login page. First, let's go ahead and uncomment this code so that whenever we start the app in the testing environment, we've got an account already created for us. And then from within the home page here, we can go ahead and add an action. An action will show up as part of a menu button that appears in the top right of the page. We'll add an action item. Its title text could be log out. It could have a description text of log you out of your account. It can have a color of red, an icon data of icons.logout, and then whenever you perform, you're given the context, but we don't need this here, so I'm going to use an underscore here. And then we're going to await context.authCoreComponent.logout. And then we're also going to await context.warp2 the login route. Warp2 will replace the entire navigation stack with just the login route, as opposed to push, which will add the login route on top of the home route. In this case, we want to completely replace the entire navigation stack with just the login. So let's check this out and see if this works. We have a menu button over here, and when we click it and we click log out, we're taken to the login page, which is great. Let me clean this code up here a little bit, and let's go to the login page and make it so that logging in will take us to the home page. If we go underneath this login function over here, we can add await context.warp2 home route. And let me copy this and add this to the sign up page as well after the user has signed up. Let's restart the app just to make sure everything works fine. We log out, and then if we log in with our credentials for our fake sample account and we click login, it takes us to the home page. Let's also check the sign up. If we sign up with Jake, and I use jake@jake.com with some random password, and we click sign up, we are taken to the home page. Currently, even though you're logged in, you still are able to force yourself to enter the login or the sign up page by just typing it into the URL bar here. Let's go ahead and add a route guard so that if you're logged in, you cannot access the login or the sign up page. This is easy to do. We're going to go to the login page to start with. And if we go ahead and we add a redirect here, with redirect, and let's go expand this function, we can quickly check if context.authCoreComponent.loggedInAccount is equal to null, or if it's not equal to null, if the user is already logged in, we're just going to return the home route.route data. Otherwise, we're going to return null. We're not going to redirect them if they don't have an account. Let's go ahead and try this. Let's restart the app. So we're currently logged in, but if we try to access the login page, it's going to just redirect us back to the home page instead of the login page. Now let's add the same functionality to the sign up page. You may be tempted to just copy and paste this entire thing, which would work, but let's actually make it so that this is a composable function that we can easily add to any other page as well. Underneath the presentation directory, let's add a new directory called util, and let's add redirectutils.dart. Here, we can add extensions to app pages that'll allow us to easily describe the functionality we want to add. Let's create an extension here called redirect app page extensions on app page. We do need to add a generic here, so we need to make it so that this extension extends on extends route, and we need to make sure that we import the correct route from Flood, not from material. Now we can add an extension here of app page of R only if not logged in, and then we can return this redirect that we created earlier. Return with redirect like so. Let's import home route. And now what we can do in the login page here is instead of having this verbose redirect, we can replace this entire redirect with only if not logged in. This is much more descriptive as to the functionality here instead of trying to read and understand the code. We now know that the login page will work only if you're not logged in. And let's go ahead and check the functionality just to make sure it works. We can go ahead and see here that if we try to log in, it forces it back to the home route. Now we can add this functionality really easily to the signup page by just copying this, going to the signup page, and adding this over here. Now, if we also try to access the signup page, let me actually go ahead and restart the app first. If we try to access the signup page, we're also redirected to the home route. Let's go ahead and add one more util here, except instead of only if not logged in, let's go ahead and make it only if logged in, only if logged in. And let's go to the home page we had a redirect over here that checked whether you were logged in or not, and if you're not logged in, it redirected you to the login route. Let's copy this logic, add it over here, and let's import the login route. Now we can replace the home page's redirect here with only if logged in. This is much more descriptive of what the home page does, and we can easily add this functionality to many other pages in the future as well. Let's go ahead and double check this. If we go to the home page and we log out, we're now on the login page. And if we try to go to the home page regardless, it's going to redirect us to the login page whether we want to or not. Let's go ahead and start working on creating our data models so that we can save users and to-dos to our database. To do this, we're going to go to our core project under lib. We're going to create a features package, and within here, we're going to create both users and to-dos. Let's start with our user data model first. In here, we're going to create 3 files: user.dart, userentity.dart, and userrepository.dart. Flood uses the domain-driven design principles for data modeling. A repository defines where we're going to store data. A value object defines what the data looks like and provides any validation. And an entity defines where to find value objects within the repository. In this case, Flood uses an ID that the repository can use to locate a specific value object. Let's start with our value object here, the user file. We're going to create class user extends value object. We're going to make sure we import from the core project, and we're going to need to define 2 properties here. We're going to define a name property, which is going to be of type string, and we're going to make it so that it's not blank. And then we're going to define an email property here, which is going to be of type string. It's going to be not blank, and it's also going to be email. This is going to add email validation here. And then let's go ahead and register these properties to our value object. We're going to override the behaviors getter. We're going to pass name property, email property, and we're also going to pass in a custom property here called creation time, which stores the time that the value object was created. This defines the shape of our data. Let's go define the entity. We're going to create class user entity extends entity of type user. We're going to import both of these, both the user and the entity, from the core project. And then here, this is all we need to do. You could, if you want, tap into the lifecycle of an entity. For example, if there's some logic you want to run before an entity is deleted, you can override this. Or if you want to run some logic after an entity is saved, you can write this. You can learn more about the lifecycle of entities in the drop page in the docs. Now let's go define a repository. We're going to create user repository is a repository wrapper. And we're going to wrap the repository like so. It's going to be a repository.forType, and this is going to be a repository that handles user entities and user value objects. We're going to add an override annotation here, and we're going to import both of these. And now we need to pass in functions to create new user entities and users. Let's do userEntity.new and user.new. We also need to pass in the entity type name, which in this case is user entity, and the value object type name, which is going to be user. We need to pass in these strings because whenever you run Dart in a minified setting, such as Flutter Web, we need to make sure that we can still find out the exact class names so that we can save and serialize these values in our states. All we've defined so far is what the data of the repository is. This handles user entities, but we need to actually define where it's going to store this data. You could, if you want, store data in memory, or in the file system of the device, or in a cloud environment. But we're going to be using the adapting repository here under the user's path. The adapting repository is going to take a look at the current environment and use that to determine where to store data. In the testing environment, it's going to store data in memory. In the device environment, it's going to store data in the device file system. And in an online environment, such as production, it's going to store data in the cloud environment that we define, which later we're going to define as Firebase. That's all we've got to do here. Let me go ahead and copy these and paste them into the to-do section and replace all instances of user with to-do. There we go. We've created all of our files for the to-do data model as well. Now let's go define the fields for the to-do value object. We're going to add a name field here, which is going to be of type string, and it's going to be not blank so that we can't type in just spaces or tabs. And then we're going to add another field here for description, and this is going to be an optional description that the user can type in. We're not going to add the dot is not blank because it could be blank. And we're going to add multi-line here so that whenever we're editing or creating a to-do, the auto-generated form is going to have a text box here instead of a text field. Let's also add a field for completed, whether the to-do is completed or not. It's going to be of type bool, and we're going to add a fallback here so that if we don't specifically describe whether the completed is true or false, it's going to default to false. And one more field here we're going to add is the user field. This is a reference to the user entity that created this to-do. You could, if you want, use a field of type string and store the ID of the user, but we're going to instead use a reference of user entity instead. This is a shortcut that uses a string field behind the scenes that stores the ID of the user entity, but this just helps us as developers understand exactly what this property stores. Now let's go and save all of these into the behaviors here. There we go. We've defined our data models. Now let's go and register these repositories into our core pond context so that Flood is made aware of these repositories. If you go to pond.dart over here, at the bottom, you're going to see a section for register repositories here. Let's await core pond context.register our to-do repository, and then await core pond context.register our user repository. Now, whenever we start our app, Flood is going to be made aware that it saves to-dos and users with these repositories here. Now let's go ahead and start actually using these data models in our app. The first thing we're going to want to do is make it so that every time a user signs up, a user entity is created and stores their information that they filled out in the sign up page. To do this, first, let's go into lib main.dart from the app project, and let's turn off this function that automatically creates an account whenever we start the app in the testing environment. Now what we want to do is, because we've added some files in our core project, our app project needs to be updated to recognize these new files. What we need to do is we need to run mellos bootstrap or mellos bs so that the app project now is made aware of the new files. Then we can go into our signup page and go ahead and create a user entity whenever the user signs up. After they sign up, the return value from this is going to be an account. If you want to learn more about what accounts are, check out the auth module in the docs. But for now, we're just going to be using the account ID. What we're going to want to do is we want to create a user value object like so. Let's go ahead and import it. We're going to want to set the name property equal to the results.data of name, and also the email property equal to the results.data of email. This is getting the result from the port submission, and we're setting it to the values of the user. Now we want to create a user entity like so, and we're going to want to set the value object of this entity to the user we just created. Typically, you wouldn't need to set the ID manually of an entity, but in this case, we want to make it so that the IDs of a user entity is the same as the account ID. We can do so like this. Now we can save this into a repository. We can do so by calling context.dropQueryComponent.update user entity. This is going to grab the entity, check whether an entity with the same ID exists or not. If it does already exist, it's just going to overwrite that value with the new value object. And if it doesn't exist, it's going to create the new document and set the value of that document to the user value object here. Let's go ahead and take a look. If we restart the app and we go into the sign up page and we type in some random information here and we click sign up, we're going to see that we have called update and we've created a new user entity. This doesn't really help us though. Let's take a look at the debug page to learn more. If you go to the debug page and you go to the drop page over here, you can see a list of all of your repositories. We can click into the user repository and see that there is an entity stored here. We see the ID of the entity, the name, the email, and the creation time. We see that we were able to successfully save the user over here. Let's also now make it so that whenever we start the app, let's go ahead and add this ability to automatically create an account for us. But let's also go ahead and make it so that we create a user entity just like we do in the signup page. Let me copy all this code that we've created here, paste it in here, set all our imports, and we're just gonna manually set the name to Jake, and we're gonna set the email over here to asdf@asdf.com. We're gonna import the user entity, and we're once again gonna need to grab the account from here, like so. And then we're going to, instead of calling context.dropQueryComponent, we're going to do core pond context.dropQueryComponent. Now we can restart the app, We can take a look again just to double check that we do have an entity here. And we can see that we still have a user entity here. We're able to successfully create user entities whenever we sign up. Let's go ahead and make it so that instead of just saying hello in the homepage, it's going to say hello and then the currently logged in user's name. The way we can do that is by going to the homepage, and then here we're going to add final logged in user ID is equal to use logged in user ID or null. We saw this functionality earlier in the video where we showed the ID of the user in the login page. We're just using the same functionality here. We're adding or null over here because whenever you do log out, it's going to be null for a few milliseconds as the page transitions out and gets replaced with the login page. We don't want an exception to occur here, so we're going to use or null to make sure that no exceptions happen whenever there is no logged in user. With this, we now need to grab the currently logged in user entity, not just the ID. The way we can do this is by calling final logged in user model is equal to use entity or null of user entity, and we're going to pass in the ID of the user entity we want to listen to. We want to listen to the logged in user ID. What this does is it's going to essentially run a query in the background, and then every time that this entity with this ID gets updated, it's going to rebuild the page with the latest information in this model. This is a model, it's not an entity. A model essentially allows listeners to easily listen to a reactive data stream of entities or any other types. This in and of itself doesn't really do much on its own. Let's wrap this styled page in a model builder, which will automatically listen to the model, and then it's going to show a loading indicator if the model is loading. It's going to show error text if the model has an error, and it's going to run a builder if the model is successfully loaded. You can learn more about models and builders in the models page in the docs. This model builder, it doesn't provide us a context, it provides us the return from a model. But what's the model? Let's pass in the logged in user model like so. And then this is going to return for us a user entity, a nullable user entity, because we are passing in or null over here. If the user entity is equal to null, we're going to return just a styled loading page, just a scaffold page with just the loading indicator in the center. But if the user entity is not equal to null, we can use its values within this styled page that we're creating over here. In this case, we're going to add the user entity.value, and the value is the current value object. Then we're going to get the name property's value, like so. Let's go ahead and see what happens. We see that hello Jake appears over here, which is awesome. If we were to add some functionality to edit the currently logged in user's name, for example, if there's some kind of a form that shows up over here that allows us to edit their name, this page would rebuild automatically every time the entity gets updated. Now let's make it so that we can actually create to-dos. We're going to add a button here in the home page that allows us to show a form where we can fill out the form, input the information for the to-do, and then create it. So let's go ahead and replace this hello world with a button. We can see that the body of this home page is a column with scroll bar. Let's also make the scroll bar centered here. And then we're going to replace this styled text with a styled button. .strong. Its label text is going to be create to do. We can add an icon here if we want. Let's do icons.add. And then let's make it so that whenever you press it, it's going to just for now print hello. We've got a to-do button over here. And now let's go ahead and make it so that a form shows up whenever we press this. What we can do is we can await context.show styled dialog, and we need to pass in a dialog that we want to show. We can do a styled port dialog, which is a dialog that's going to automatically generate the UI based on a port that we create. You've seen earlier how an UI can be generated from a port, as we did in the login page and the signup page. Let's go ahead and create a port based off of a to-do object, and then show the automatically generated UI from that. So first, what we can do is for the port, we can create a to-do is equal to to-do. The port that we want to edit is going to be based off a blank to-do. But it's not going to be just a blank one. We're going to want to set the user property of the to-do to the currently logged in user ID. This is going to make it so we create a new to-do and we pass in the currently logged in user ID as the user for the to-do. Now what we want to do is the port we're going to pass into this dialog is going to be todo.asPort. And we need to pass in a corresponding context, which we can get using the build context like so. Let's also, for this styled part dialog, let's pass in a title text, which is going to be create to do. Let's see what happens. If we run this, we're going to see a create to do, and we're going to see a few fields showing up here. They're not labeled or anything, so let's go ahead and fix that. If we go to todo.dart, we can modify these properties over here by adding .with display name. So for the name property, we want this display name to be name. We're going to want this one to be description. The completed property, we actually don't want showing up in this form. We want to make it so that this completed property will show up to the left of the card itself. So let's actually make this hidden, so it's not going to show up. And by default, Flood will not show any reference fields within the edit forms. But just to be really clear, let's go ahead and add hidden here as well. Let's restart and see what happens. We click here, create to do, and the form UI is completely generated for us automatically. We're not quite done yet here. Let's go back to the home page, and inside of this dialog, let's go ahead and add an onAccept. This is going to give us a callback that we can use whenever the user clicks OK, and it's going to create a to-do for us based off the input that the user has typed in here and allow us to do whatever we want with it. For now, let's just print the to-do to see what happens. Let me go ahead. For the name, I'll just do take the trash out every Sunday. I'll click OK here, and we'll see that we're getting a result printed out here. It's a to-do whose name is take the trash out, and the description is every Sunday. The user that is passed in is the currently logged in user ID, and we've got a creation time here as well. This is awesome. This functionality here is able to completely generate the create form here for us, automatically figure out what the fields should be. It grabs those field outputs and inputs them into the value object that we can then do whatever we want with. Before we count this done though, let's go ahead and save this to-do to the database. What we can do is create a final to-do entity is equal to to-do entity, and we're going to set the value object of this entity to the to-do that was passed in here. Essentially, we're creating a brand new to-do entity whenever we create a new to-do. But now we need to go ahead, await context, .dropCore component, .update to-do entity. Let's go ahead and make this onAccept also asynchronous, and let's rerun to see what happens. We can create a to-do, take the trash out every Sunday, click OK, and while we don't see anything here yet, let's go ahead and check our drop debug page. If we go to debug, click go, drop, go to the to-do repository, we do see that an entity is successfully saved here, and we can see all of its fields here look exactly like what we expected. Awesome. Now let's go ahead and actually show the to-dos on the home page. What we can do is in the home page, we're going to go up and we're going to create a new value here called final to-dos model is equal to use query. Here we're going to run a query and then update the query result every time any to-do ever changes. So this query that we're going to run is query.fromToDoEntity.whereToDo.user field is equal to the logged in user ID, and we're going to get all of the to-do entities like this. Essentially, every time this query ever gets updated and the very first time that this page is built, it's going to rerun this query, and then we're going to get the value back as a model. Now, just like with a logged in user model, we're going to have to use a model builder to build this so that we can show an indicator whenever it's loading and error text whenever there's an error. We could have another model builder within this model builder, but there's an easier way. We can use a model.union and pass in a list of models, and this model.union is going to update anytime any of its inner models gets updated. So let's pass in the logged in user model and the to-dos model within this union. Now in the builder here, instead of passing us a user entity like so, it's going to pass us a list of results, which we can then use pattern matching to extract. We're going to grab to-do entity of to-do entities is equal to results. Now we've got both the results from the logged in user model and the to-dos passed in here. Now what we can do is we can go down underneath the button here, and we're going to show a list of all the to-dos that the user has created. Let's go ahead and do to-do entities .map to-do entity. And for now, let's just show a styled card whose title text is going to be the to-do entity.value.name property. And then it's going to have some body text that is the to-do entity.value.description property.value. And now let's go ahead and cascade this So it's going to look like this. Let's see this in action. We see take the trash out. Let's create another to-do. Let's do test. Okay, and we see another one here. Notice I didn't have to do any state management, nothing custom. It just automatically worked. Whenever I created a new to-do, the page was rebuilt with all the latest to-dos. Now let's go ahead and make it so that we can edit and delete these to-dos. What we can do here is pass in a list of actions to the styled card, and we're going to pass in 2 action items. Let's start with the edit one. The title text for this one is going to be edit. The description text is going to be edit this to-do. The icon data could be icons.edit, and the color could be orange. And then for onPerform, we're going to await context.showStyleDialog, and we're going to show another styled port dialog very similar to creating a to-do. And the only difference here is that instead of creating a new to-do, like in this case, whenever we're creating a to-do, we're creating a new to-do and then calling this to-do.asPort. What we're going to do here instead is instead of creating a new to-do, we're going to use the currently existing to-do within the entity.asPort, like so. That way, it's going to create a port whose initial values are whatever we currently have in this to-do. Let me also go ahead, fix the formatting here a little bit. Let me add some title text of edit to-do, and then on accept, let's go ahead and print out what the to-do is, the modified to-do. We see the menu buttons over here, and we would click here and click edit. It's going to show an edit form for us, automatically generated once again, and it even pulls in the initial values from the to-do that we created earlier. So take the trash out, and every Sunday shows up here automatically. I didn't have to do anything custom to get this working. Now, let's do test at the end of the name here, and test at the end of the description, and click OK. And we're going to see that the printed to-do here, we have test at the end of the name, and test at the end of the description. It automatically parses out the fields once again and creates a new to-do for us to do whatever we want with. Let's go ahead and update the to-do like so. Let me first make this asynchronous, then await context.dropCoreComponent.update. And in this case, we're going to do to-do entity.setToDo. We're going to use the same to-do entity. We're just going to set its value to the new value object here instead of the existing one. Now, if we go ahead and we save this and run this, and we add test at the end here and click OK, we're going to see that the list was automatically updated, it was saved into our database, and once again, I didn't have to do any custom state management, it just works. Now let's go ahead and add the delete functionality. To do this, let me first clean up the code here. Let me add another action item whose title text is going to be delete. Description text is going to be delete this to-do. The icon data could be icons.delete. The color could be red. And on perform, I'm going to first ask the user a yes or no question. I want to confirm whether they want to delete it or not. I'm going to await context.showStyleDialog, and here I'm going to use styleDialog.yesNo. The title text is going to be confirm delete to do, and the body text is going to be are you sure you want to delete this to do? You cannot undo this. Now, if they accept anyways, we're going to run this function over here. And this function that we're going to run is going to be await context.dropCoreComponent.delete the to-do entity. Let's see this in action. We have a new button over here, delete. And if we click here, then we cancel, nothing happens. But if we do delete this test to-do, for example, we can see that it has been removed from the list automatically. Once again, no custom state management was necessary. It just took care of it on its own. What we want to do now is add a checkbox at the beginning of this card here where we can indicate whether the to-do has been completed or not. To do that, we can go into the place where we're generating the cards for every single to-do entity, and we can add a leading widget over here. We're going to add a styled checkbox, and here the value of the checkbox is going to be the to-do entity.value.completed property. And then whenever we change this, we're going to have a new value here. And what we want to do is we once again want to update the entity, await context.dropCoreComponent.update, except we're going to use this helper here called update entity. We're going to pass in the to-do entity, and then this helper allows us to grab the current to-do from this to-do entity and then modify it before we save this entity. So in this case, we want to grab the to-do and we want to set the completed property to new value, like so. So we see a checkbox over here, and when we click into it, we're going to indicate that it has been completed. And you can see in the logs here that we are actually updating this entity in the repository, and then we can uncheck it to indicate that it's not completed anymore. Let's go ahead and check it as completed and see what it looks like in the drop debug page. If we go to debug, go drop to do, we can see that this to do over here has been completed. There we go. We've completed all the basic functionality of our to do app. So far, we've been doing all of our testing in the testing environment. Now we're ready to transition over to other environments to see what it's going to look like. Let's first do some more testing in the device environment to see how everything gets persisted across sessions. To edit the environment, go to the app project, assets, and then config.overrides.yaml, and let's set the environment over to device. If we restart the app, we're going to see that we're in the device environment, and we're going to see that it takes us immediately to the login page. That's because in our device file system, we don't have a currently logged in user. Let's go ahead and create one. Let's go to sign up. I'm going to create Jake with this email and my password, sign up, and it takes me to the home page. Let me create a to-do here called take out the trash every Sunday. Okay, sweet. Now let me restart the app and see what happens. If I restart, we see that it takes me directly back to the home page with this to-do that I created in the last session. Everything is stored on device. You can take a look for yourself by going to the debug page here, going to the device files, and you can see some folders here such as to-dos, and you can see the JSON of the to-do that we created, and you can also go and see the user that we created as well. The last thing we need to do in order to complete this project is to set this up with Firebase. Let's go ahead and do that. The first thing we're going to need is we're going to need to go to the terminal, and from within our app project, we're going to need to run Flutterfire configure. There are instructions on how to download Flutterfire and how to just do all of the Firebase integration yourself in the Firebase integration docs. It's going to ask which Firebase project to configure with. I've created one here. I'm going to configure it for Android, iOS, and web. Click enter, and it's going to generate all the projects for me automatically. Sweet, it generated. And if I go into the lib here, I'll see that there's a Firebase options file here that I'm going to add to Git. Now what we need to do is go to the main.dart, and we're going to need to customize our app pond context a little bit to configure Firebase. The first thing we're going to want to do is whenever we're generating the core pond context, we're going to need to quickly add in an initial core component of the Firebase core component. We need to pass in the app here, which in this case, let's go ahead and grab that from our Firebase options. It's going to be default Firebase options dot current platform. The import here is acting a little funky. Let's go ahead and just import it ourselves. Firebase options. There we go. And let me fix this package to be in the correct format. There we go. Now, whenever we launch the Flutter app, we're going to immediately initialize this project to work with Firebase for this app right here. Now what we need to do is go ahead and integrate what auth service implementations and repository implementations we have. Because Pond is allowed to work with multiple different types of cloud providers, such as Firebase or AppWrite and eventually Supabase, we need to specify which exact repository and authentication service we want to use. Let's first add an auth service implementation here, like so, and then let's use the Firebase auth service implementation. Let me also edit the repository implementations to allow Firebase Cloud Repository Information. Now let's run Firebase init from within our core project so that we can see what the Firestore rules and indexes look like. So from within the core project, I'm going to create a new directory here called Firebase, my cd into it, and then I'll run Firebase init. I'm going to just initialize Firestore here. I'm going to use an existing project, and I'll use the project that I created for this example app. I'm going to set the defaults for both of these files here, and it's been completed. Now, from within here, I'm going to git add the entire directory over here. And now what we can do is see that the Firestore.rules here, the Firestore rules have everything as false. We can't read or write anything from within the app. Let's go ahead and update the security rules so that we can actually use the app in production. Now you could, if you want, manually write all of the rules for all of your collections, but we're actually going to tap into Drop's automatic Firestore rule generation to do this for us. The The first thing we're going to need to do is go into our repositories that we generated earlier and define some security for them. Let's open up the to-do repository and add a .with security at the end here, and let's pass in a repository security. By default, you're able to customize exactly what permission you'd like for every single one of these 4 operations: read, create, update, or delete. But for now, we're going to use repository security.all so that we can pass in just one permission that'll apply to all operations. The permission that we're going to create is going to be permission.equals, where we're going to check whether the permission field property name of todo.user field is equal to the currently logged in user ID. Essentially, we're only able to read, update, create, or delete to-dos if the user field of the to-do, which is represented by this user property over here, only if that field is the same as the currently logged in user ID. Now that we've got that, let's also modify the user repository. Here, we're going to add .with security, and once again, we're going to do repository security.all. And we're only going to be able to do any operations in here if the permission.equals permission field.entity ID is equal to the permission field.logged in user ID. So we're only able to do any operations on a user if the ID of the user is the same as the currently logged in user ID. Let's go ahead and modify this so that the delete here is going to be permission.none. We don't want to allow anyone to delete users ever. That should be just handled on the back end. Before we run the Firestore rule generation script, let's first go into our app project and set the environment over to production. This is going to make it so that our CLI script is going to run within the production environment instead of within our device environment. With that, let's go over here into our core project and let's run dart tool/automate.dart deploy production. When we click enter here, it's going to generate the Firestore security rules and then automatically deploy them for us if it looks good. We're going to see here that it's going to offer a suggestion for us to install this tool here because we don't have it. And then we're going to see that we need to run with this flag again because Dart has been changing how scripts are run, like so. And then it's going to say that environment for production does not exist. Would you like to create it? And we're going to click yes. It's going to automatically configure this Firebase project for us so that it knows that whenever we're in the production environment, it should be linked to this specific project that we're going to choose. I'm going to use the to-do app project. I'm going to use production as the alias here. Now it's showing us what a diff is for the firestore.rules file here. We could look at this diff here. It's going to be a bit hard to understand. Let's actually take a look at the file that it generated itself. Note that I didn't have to do any of this. It literally extracted this information from the repositories that we defined and generated these rules for us. We can see that for the to-dos collection, its security rules are that it allows any of these operations as long as the user property of the to-do is equal to the currently logged in user's ID. And then for the user, it only works if the ID of the user entity is the same as the currently logged in user ID, but it never allows deleting. This looks great to me. Let's click yes to execute the plan, and it's going to automatically deploy the rules for us. And there we go. We're now ready to use the production environment in our app. Let's go ahead and see how our app functions, and we'll have Firebase pulled up on the side for us to take a look. Let's go ahead and create a new account. I'll use the same email and password I've been using before. Click sign up, and it takes me to the home page here. Let's refresh our authentication page here, and we see that a new user has been created. Let's also go over then to Firestore and check out if the user entity has been created. We do see a user entity over here. Let's now create a new to-do. Take out the trash every Sunday. Click OK. And now let's refresh the Firestore page. And we see that the to-dos has been created. Let's go ahead and complete this. And we see that the completed has been updated. And now let's go ahead, edit this, take out the trash test. We see that the name has been updated, and now let's go ahead and delete this, and it's gone. We see that in production, everything works just as you'd expect. And there you go. We've built an entire to-do app in less than an hour and a half. In this app, we have a full authentication flow with logging in, signing up, and logging out. We have data models for to-do and users. We automatically create a user whenever a user signs up. We have emulated repositories and services whenever you're testing, and full integration with Firebase, along with Firebase rule generation. In addition, we created the app icon as well. I hope this video shows you the benefits that Flood provides. If you have any questions, let me know down in the comments below and I'll answer them. And there's going to be links in the description if you want to learn more.